Hello, everyone. Welcome to Data Analytics using Python. I'm your instructor, Michael Galernik. This is a video on course logistics, so what the course covers, how to reach me, how to install Python for your operating system, and the rationale for why we're using Python in particular for data analytics. Before continuing, I should note the vast majority of our lectures aren't going to be slide-based. They're going to be using Jupyter Notebooks, and I'll get to what those are in a future lecture. So first things first, if you need to reach me, my email is mgalarny@gmail.com. Contact by email is preferred. However, if necessary, I can set up a Zoom meeting. And for all emails, I ask that you indicate data analytics using Python in the subject line. Otherwise, I won't know which of my classes you're referring to, as I tend to teach quite a few courses. In this course, we'll primarily have one assignment, which accounts for the majority of your grade. And that assignment will be posted on the Blackboard site under assignments. For in-class exercises, they'll typically be in our lecture section. And students are responsible for logging into the Blackboard site periodically, as that's where lectures will be posted, materials, etc. As far as seeking help in this course, the instructor will not be able to rigorously debug each student's projects. However, if you have a code error that really has you stumped, then the source code and associated error message can be copied and pasted on the course discussion list. You could also paste your code and errors on the unlisted YouTube video if you wish. I will respond to that as well. If you're working on your project, which is the main assignment for this course, I ask that you also send me any data you're working on, as a lot of times, a lot of issues can be solved by looking at the data itself. This is what we'll be covering throughout the course. So session 1 and 2 will be installing Anaconda, Python, as well as Python basics, strings, lists, etc. I'm a really big believer in going over the basics, as even advanced Python programmers still look up the basics from time to time. Additionally, this is a class typically with students from all sorts of backgrounds and experience in Python. And I want to bring everyone to a common level of competency in programming in the context of complex and noisy data. Session 3, we'll be going over Pandas, which is a Python library used for data manipulation and analysis. This is really a core part of the class, as it's very important to be able to load, manipulate, and export data. Session 4 will be diving deeper into Pandas, as well as starting to go over how to plot using the matplotlib library in Python. And a lot of data analytics, data science is really just communicating results, and graphs really help with that. Additionally, if you're into machine learning, viewing your metrics on some sort of graph typically helps in improving and understanding your model. Session 5 will be more plotting, as well as going over our first classification algorithm of logistic regression, and also how it works. Session 6 is really my favorite lecture for this course, as we'll be going over decision trees. Session 7 will be going over our first ensemble machine learning method, random forest. Session 8 is probably one of the most difficult topics to cover for this class, as we'll be going over clustering and dimensionality reduction. So just a heads up, session 8 might take you a little bit more studying time for that week. And session 9, we'll be going over topics of interest and how to learn them. And this is really just a lecture telling you what we didn't have time to cover and how to learn these topics if they interest you. The class structure of this course will be mostly lessons, so lecture videos. Typically, they won't be PowerPoint based. You'll download exercises, we'll go over exercises, you'll do them on your own, and then look up the solutions on the video corresponding to those exercises. And we'll also have supplementary material. As this is a 9-session class, I can't cover everything into extreme depth. So I'm giving you supplementary material so you can learn topics more completely if you wish. In this class, we'll be using the Anaconda Python distribution, a Python 3 version preferably. I do ask that when you're going to install Anaconda, please use these links. The rationale being, besides the fact I spent quite a bit of time making these tutorials, I do ask that for Windows users, please look at step 6 and the alternative approach. This might save you quite a bit of time if you're dealing with issues later on in the class. For Mac users, it's pretty simple to install Anaconda, but I do ask that you also use these links. As far as why we're using Anaconda in this class, Anaconda is a strongly recommended way of installing Jupyter, which we'll be using for this class. Anaconda is also a package manager, environment manager, and Python distribution. If that doesn't make sense to you, think of it like this. If you need to install additional libraries, it really helps to have a package manager that can ease that process for you. And we'll get into that in a little bit. Additionally, perhaps the most primary reason we're using Anaconda is most data analytics projects require multiple different libraries, packages, NumPy, SciPy, Pandas, Scikit-learn to name a few. And that's something Anaconda already comes pre-installed with. And I know for some of you guys, you may come from a class where you're using Python 2. Anaconda makes it easy to switch between Python 2 and Python 3 environments. However, since it's not a DevOps class, I don't mind if you absolutely insist on using Python 2, even if Python and major libraries are dropping support for it in 2020. And we'll go over more of Anaconda later. One of the reasons why we use Python for data analytics is its increasing popularity as a programming language. So the graph on the right of your screen is a percentage of overall question views on Stack Overflow each month over time. So it's pretty clear Python is becoming a more popular programming language. One of the major benefits of this is that there's a Python library for everything. And the real benefit of having a Python library for everything is typically you don't have to do a lot of things from scratch to accomplish your analytical goals. Consequently, we'll go over how to do a lot of tasks using Python libraries while going over the theory of how things work behind the scenes. One of the things that people are most curious about when they take this sort of class, typically, is making predictions on data. In this class, you'll see that before you can make predictions on data, you first need to know how to use Python to load and manipulate data. And oftentimes, for certain data sets, you can't even predict on that data set, as you don't have enough data or even the right type of data. Say you're able to make some sort of prediction on your data. Even then, you'll need to be able to explain how your predictions work, which we'll heavily cover in this class. And in this class, we'll be using Jupyter Notebooks, and we'll go into a full lecture on what Jupyter Notebooks are next. But think of them as a way to represent both code and rich text elements, such as figures, links, and equations. And with that, I recommend you go on to the next lecture, where I'll be showing you guys how to open a Jupyter Notebook, how to do certain things in it, as well as go over Python basics.